Okay, the last section on today's class is about the graph-based method. Okay, and this is a method to handle the sparsity problem. Okay, do you still remember sparsity? The sparsity means when we have a lot of missing values. So the missing values by product yet, or the users did not visit the restaurant yet, or the users did not like the product, but they do not want to give the rating and etc. There are many reasons for that one. So for to handle this kind of sparsity problem, there is another method. They call it spreading activation. The method exploits the supposed transitivity. Okay, so as I mentioned before, the transitivity, it is the kind of transitivity of the customer taste and thereby augment the matrix with additional information. So assume that we are looking for a recommendation for user 1. So we are looking at the user 1. We can use the standard CF approach. We can use the CF is the collaborative filtering approach. In this case, user 2 will be considered a peer for user 1 because they both bought item 2 and item 4. Let's see. Using this graph, user 1 has the line to item 2. User 1 has a line to item 4. So I know that user 1 has bought item 2 and user 1 has bought item 4. What about user 2? User 2 bought item 2, item 3, item 4. With the standard CF approach, okay, user 2 might be the closer to user 1 compared to user 3. Why? User 3 bought item 1 and item 3. Okay, so let's see again. User 1 bought item 1, item 2 and item 4. User 2 bought item 2, item 3 and item 4. Meanwhile, user 3 bought item 1 and item 3. So with the collaborative filtering, we want to find the similarity of the users, or we want to find the similarity of the item. In this case, I know that the user 1 is closer to user 2 because they have the item more similar compared to user 3. Now, using this information only, we can say that, okay, item 3 will be recommended to user 1 because the nearest neighbor, which is user 2, also bought or like it. Because we know that the user 2 bought item 2, item 3, and item 4. So I can recommend the item 3 to user 1. Because I know that when the user 2 bought item 3, because user 2 also bought item 2 and item 4. Then if user 1 has the item 2 and item 4, most probably he or she will like item 3. Then we can recommend item 3. So this is the graph-based method. And now, in a standard user-based or item-based CF approach, path of length 3 will be considered. What does it mean by path of length 3? So you can see item 3 is relevant for user 1 because there exists a 3-step path. So user 1 to item 2 to user 2 to item 3. So we have 1, 2, 3 path. Okay, we call this is path of length 3. So from user 1 to item 2, and then item 2 has been bought by user 2, and user 2 bought item 3. So we have 1, 2, 3. So the length is 3. Okay. Because the number of such path of length 3 is small in sparse rating database, the idea is to also consider longer paths. The longer path means somehow there might be some indirect association to compute the recommendation. For example, we can use the length 5. If we use the length 3, then user 1 can be recommended to item 3. But what about if we use length 5? If we use length 5, okay, let's see. The idea is use the path length higher than 3 to recommend item. It means if the length 3, I will recommend item 3 to user 1. So user 1, 1, 2, 3. Okay. But what about if I use the length 5? So if I use the length 5, then I will go from item 3 to user 3. And from user 3, I can select other item which has not been selected by user 1, which is item 1. So we have 1, 2, 3, 4, 5. So the length is 5. Okay. And using this one, okay, with the length of 5, I can recommend item 1. So not only item 3, but we can also recommend item 1 to user 1. So this is using the graph-based method. Okay. So this graph-based method, we can also apply with the problems that we have before. If we use this one, is it possible to use the graph-based method? All users already give rating to all items. Okay. So it is difficult to make the graph method like this one. So the graph method is good for the sparsity. The sparsity means something like, oh, where is the where is the example? Where is the example? Oh, I forgot. The number. Oh, okay, this one. So we some missing done, so we can apply the graph-based method for this one. Okay. Okay, so the last one that I want to explain is, so you can see the line one, we have 1, 2, 3, this is the length 3, and then we have length 5. 1, 2, 3, 4, 5. Okay. My question. Even number. Two. It will go to the user. Okay. It will go to the user. So we cannot recommend any items. So the length to be odd number. This is also one limitation of the graph-based methods. Okay. Yeah, of course, you can also make this an issue for can handle this limitation. Yeah, that will be good. For example, if I not the so which or still like this item. So there's also another issue that we can try for the sparsity problem. Okay. Now, to so you can use the user base. If you use the user base collaborative filtering, it means you can measure the similarity with the person correlation. Okay. Or you can try with item based collaborative filtering, and you can use the cosine similarity. So, item based. The problem is now you need to use the person correlation. And first, you need to measure the similarity, and the next, you can predict the rating. In the user base, we use the Quotient correlation. For the item base, we use the cosine similarity. So today, so for easy calculation, yeah, in the exam, maybe I will give you one problem like this one. So you need to calculate. You can bring your calculator. So you will show what is the predicted rating from this one. For this problem, let me use Excel. Actually, you can use Excel to do this one as well. Okay. So this is the rating. Okay. So in the Excel, you can you can measure the average of rating from user 1, user 2, user 3, user 4, user 5. So we can get the average. And after we get the average, we can do with the person correlation. Now, there are two things that we need to look at. The first thing about the average. But the basic collaborative filtering, we will use all of them. Okay? The basic one, we will use all of them. So this one is using all of them. And this one is using only 4 items. Okay? From C until F. From C, D, E, and F. So for the person correlation, I use this one from the 4 So you can check later if we use all 5 items. So you can use the person correlation. The person correlation here, it is a formula from the what is the factor that you want to check compared to the information from the user. So in this case, okay, so in this case, if you do the person here, you want to compare the rating from user 3 with the rating of user 1. Okay. What about this person? This person correlation is from this one and this one. For this person correlation, we want to get from this one and this one. For this person correlation, we want to get this one and this one. Okay. Now, if you look at the result, too small. Okay. Minus 0.22. 0.19 minus 0.19 and 0.12. Which is the nearest neighbor? Using the person correlation, what? What? So now the question is, predict the rating based on the two nearest users. So in this case, what is the two nearest users? Prediction. Then yeah, you can do the prediction. So the rating in the so the rating for this one, wait a moment. Okay, this one I use the average for all items, and this one I use the average for only 4 items. Okay. So you can see with the experiment, if I use the average for all items, based on this result, so based on this person correlation, and based on the two nearest users, the value or the predicted reading is 2.4 or 2.3 something. Okay, so 2.3 something, it is based on the average of this one, plus the similarity of the user 2 and the similarity of the user 5. Okay. So you can try with the Excel this for your understanding about how to calculate the person correlation and the prediction. Okay, so I think that's all what we learned today. We learned about the pure collaborative filtering, and we learned about the user-based nearest neighbor. We learned about the person correlation. We learned about the item-based nearest neighbor, and we learned also the cosine similarity. And we handle some data sparsity problems like with the graph-based method. So for next week, we will learn about the memory-based and model-based. So still in the collaborative filtering, but we will learn more advanced approach. So what is the memory-based and what is model-based? And some recent methods like SVD. And then we are going to use the association rule. There's another method, slope 1, RF-REC, and some engine. Maybe I will not discuss Google. I will discuss about the Naver News. Okay, so how the Naver News handle the personalization engine with the collaborative filtering. Okay, that's thing we can learn until now. Any question?